Question 15. We're given a straight line, the equation of a straight line L as 2y equals 6x minus 5. We have a straight line L2 which is perpendicular to L and passes through the point 9 comma minus 1. And we're being asked to find an equation for L. And lastly, we have to write it in the form ay plus bx equals c. So L1, the line in pink, we have the equation for it, which means that we can get the gradient from that. And the reason why we're going to want to get the gradient from that is because of this statement here. With them both being perpendicular to each other, that means we can get the gradient for L2. And then from there, we're going to use the coordinates to find our equation of L2. So in order to get the gradient from the equation of a line, we need y on its own. So we divide both sides by 2, giving us the following, which tells us that the gradient of L1 is 3. The fact that they're perpendicular to each other means that the gradient of L2 is going to be the negative reciprocal of 3, which will give us negative 1 over 3, like so. From there, our y equals mx plus c is going to be y equals negative a third x plus c for our line L2. And we have the coordinates 9 minus 1 that we can sub into this in order to figure out c. So we have a third times 9 plus c, which will give us minus 3 plus c on the right, minus 1 on the left. And adding 3 to both sides gives us a c value like so, which means that the equation of our line L2 is y equals negative a third x plus 2. We're not done yet though, because they want us to give this answer in the form y plus bx equals c, which means they want the x term and the y term on the same side. So we're going to add a third x to both sides, first of all, and we will get the following. A third x plus y equals 2. Now technically that's acceptable as an answer because we have written it in that form and they've not declared that a, b and c, for example, needed to be whole numbers. So in some other questions they might tell you that they need to be integers, in which case we'd have to multiply everything by 3 here to get rid of that fraction, giving us a different looking answer but the same equation. So if you happen to have done that, you're still correct. It's just they didn't declare that a, b and c needed to be integers. So either of these answers would be accepted. Done.